Let's start by creating a new scene using Three.js. This is where all of our objects, lights, and cameras will exist. It is essentially a container for our 3D world. Next, we initialize a perspective camera. This camera simulates the way the human eye sees. It is characterized by a field of view of 75 degrees, an aspect ratio based on the browser window's width and height, and it can render objects between 0.1 and 1000 units away from it. Here, we're creating a WebGL renderer, which uses WebGL to render our scene in the browser. We're setting its size to fill the full browser window. Then, we're appending its DOM element. That's the canvas it draws on, directly to the body of our HTML document. By setting renderer XR enabled to true, we're activating the renderer's built-in WebXR support. This is needed to enable VR capabilities in our application. The VR button object provides a convenient way to create a button that lets users enter VR. We're creating this button and passing our renderer to it, which manages the display and session details for WebXR. After creating the button, we append it to the body of our HTML document, making it visible and clickable on the page. We are setting the initial position of the camera. We're placing it at a height that approximates an average human eye level, which is 1.6 units above the ground, to give a natural feeling when entering VR. Now, let's create a simple cube mesh. First, we define its geometry. That's its shape and size, with each side being 0.2 units in length. Then, we create a material to cover the geometry. Here, the mesh normal material is used, which gives the cube a color that depends on its orientation to the light. Finally, we define the mesh by combining the geometry with the material. With our cube mesh created, we add it to the scene. It is now part of our 3D world and will be rendered in the next frame. Lastly, we'll create a function called animate. Inside this function, we call renderer set animation loop, passing in another function to be our animation loop. Within that loop, we update the cube's rotation to create a spinning effect. Then, we tell the renderer to draw our scene from the perspective of the camera. This function gets called once per frame, creating a smooth animation. Finally, we call animate to kick off the loop.